Hello student of class 10, let's continue our chapter electricity, and today we are going to discuss very important topics, factors on which the resistance of a conductor depends. To understand which factor affects the resistance of a conductor, we have to discuss this experiment. So at first we have to complete an electric circuit consisting of cell, an ammeter to measure the current, a nichrome wire of length L, and plug key as shown in this figure. Now plug the key, note the current in the ammeter. Replace the nichrome wire by another nichrome wire of the same thickness but twice the length, that is 2L. Now change this nichrome wire, and instead of this you put another nichrome wire whose length is double of the first one, but the thickness is same, and again we will read the ammeter. Now replace this wire and place another nichrome wire whose length is L but thickness is twice as the first one. So area of cross-sectional area will be, suppose, 2A. Thickness we say area of cross section, and thickness we symbolize by capital A. Now again you read the ammeter. So student, remember, at first we have an wire, nichrome wire of length L, and we read the ammeter, and after that we replace this wire and we have taken double of length, that means 2L length wire, but thickness is same. So again we have read the ammeter, and after this we have again replaced this wire and we have placed of nichrome wire which length is L but thickness is 2A, that means double of the first one. So again we have read the ammeter. Now replace this again and place another wire, suppose copper wire instead of nichrome wire, and again read the ammeter. So what we will observe? Let's discuss. We observe that the ammeter reading decreases as the length of the wire is double. The ammeter reading is in thicker wire of the same material and the same length circuit. So we observe that whenever we increase the length 2L, then current amount decreases into half, and when we replaced by the double thickness wire, that means 2A cross sectional area, in that case current increases. So when length of the wire increases, then current also decreases, and whenever the thickness of the wire increases, then current also increases. And we know that whenever current will be increased, then resistance will be decreased. So in that case we can say whenever length of the wire is increases double, then current flowing through the conductor become half, that means current decreases, and if current decreases, then resistance increases. So if length of the wire is increases, then resistance is increases. So length and resistance is directly proportional. So we can write R proportional to L, because length of the wire increases, then resistance increases. This is equation number 1. And another way we have found that whenever cross-sectional area increases, current amount increases. If current increases, the resistance decreases. So we can say resistance and area of cross-section are inversely proportional. So we can write R proportional to 1 by A. Now if we apply both the equation, then we can write R proportional L into 1 by A. As a result, R proportional L by A. Now instead of proportional sign, if we want to give the equal sign, then we must take a constant, and we have taken the constant here, rho. So R equal to rho L by A. So where rho is a constant of proportionality and is also called resistivity, electrical resistivity of the material of the conductor, and the SI of the rho is omega m. So this resistivity will inform us what is the resistance of the material. Resistance is the opposition force by which current slows down. And resistance is like the frictional force only, but it takes place inside the conductor and it opposes the motion of the electric current.